Okay, we're looking at question 5, which basically says, I'm going to give you a stimulus and there's a discrepancy in it. And so can you identify what it is? And then can you give me a piece of information that would resolve it? Okay, so basically we need to identify, we've got to start by understanding what is the discrepancy and then find an answer choice that somehow distinguishes these, the discrepancy, which then allows us to actually solve it. Okay, so in answer choices, what you're looking for is something that begins to distinguish A and B. And so in this case, it's, A is rat and B is mice. We've got rat and mice, right? And which appear to be kind of like the same sort of creature. And we feed them X, which results in getting Y, and then Y causes cancer, okay? And then we break it down, we feed the mice X, they don't get Y. So something that attacks the idea of right here, this is what we're looking at. This is the discrepancy. What is causing this? This is also, the discrepancy as well, okay? But this is kind of where it is. And now you might be asking yourself, why am I not saying all these big words? Well, first off, I'm from Texas and we don't know how to say anything more than 2 syllables. Second off, it's I don't need to expend the mental energy to try to come up with understanding what these terms are. Whatever it is, we're feeding them this thing, and then they're getting this thing, and this is causing cancer. And that's all I really need to focus on. And if I can find something that helps to identify that and explain to me why this isn't happening versus that happening, then that's my answer choice. So let's kind of begin at E and work our way up. So high doses of other artificial sweeteners have been shown to produce silica crystals in mice, but not in rats. Okay, so first and foremost, we're just talking about other artificial sweeteners. It's not relevant, so it's out. Okay, let's look at D. The silica crystals are toxic only to the cells lining the bladder and not to other bladder cells. And so if you think about this answer choice, it doesn't really distinguish anything between rats and mice. It just says, you know what, when this stuff hits the bladder, it causes whatever, it has to come in contact with cells that line the stomach. Anything else it's not going to affect. Well, because it doesn't distinguish between anything, it cannot be an answer choice, so it cannot resolve our discrepancy. Okay, if we look at C, high doses of saccharin are much more likely to produce silica crystals than lower doses are. Okay, so again, that doesn't distinguish anything either. Well, we're starting out with, we know that the X is the high dosage. They're both getting the high dosage. That doesn't really resolve anything. It just kind of tells us that when you give high doses, we're going to basically have this effect that is getting Y, okay? Again, because it does not distinguish between the two, it cannot be the answer. If we look at B, cells in the bladder regenerate more quickly in mice than they do in rats. Okay, so this is the first one that we do have a distinguishing characteristic. And we're saying that the cells here regenerate faster. Okay, and this is where, I needed to be reading a little bit more critically than just throwing this out. I kind of want this to be the thumbnail in your mind, and then when you start getting answer choices, you're kind of like, okay, you're keying in. We know it distinguishes, and we're saying that these cells that line cells in the bladder regenerate more quickly in mice than they do in rats. Well, if that was to be the case, right, when the cells, we go back up to the stimulus, when the cells regenerate, some are cancerous and form tumors. Well, presumably if the mice's cell, I don't know if mice's is a word, I have to apologize for that. If the cells of the bladder of mice regenerate quicker, and the result of regeneration is the acquisition of cancerous cells, it would kind of indicate that mice would even be more would end up with cancer more. Okay, that this would actually happen even more. So not only does this not resolve the discrepancy, it actually if this were to be true, this would make it even more of a problem. Okay, so it doesn't do anything to resolve. It actually compounds the problem. It's not the answer. But let's look at A. Urine proteins that react with saccharin to form silicate crystals are found in rats but not in mice. Okay, so if we look at basically mice, don't have these urine proteins. And so what we have to what it's really doing is it's kind of establishing the connection here and here. In order, if you're fed X, you kind of need to have these urine proteins as a result of being fed this, that will actually then create Y. So what it does is it says, if this is 1, now we've been given 2 and 3. So it's almost like, you feed X, then you get, I don't know, you get A, and then you go from A to Y, okay? So here is you're feeding X, you know what, you do not get A. And if you don't get A, you can't, it logically follows that you're not going to get Y. So that does resolve the discrepancy. It basically says, look, we fed both of these guys the same thing. These end up with urine proteins that interact with saccharin or whatever. These guys don't. Therefore, these guys are not getting cancer, and these guys will end up with cancer. Okay, so A is the correct answer to the question.